Alright, today's video is over comparing rate of change. I also want you to remember that another name for rate of change is slope. Okay? In a quadratic function, we don't have a consistent slope. So what we can do is we can look at the slope or the rate of change for a given period of time to determine the average rate of change or the average slope. So let's take a look at this curve here. If we want to know the average speed from the hours of 1 to 4, all we would have to do is look at the point here, the beginning point, and the end point. So what I have here is this is the point 4, 200, and this is the point 1, comma, and that looks to be about 50. So what we would do is remember that slope is y2 minus y1 over x2 minus x1. So what we're going to do is we're going to take this. We're going to say this is x1, y1. This is x2, x2, and y2. And we're going to plug it into the formula. So 200, whoops, let's get a different color. 200 minus 50 is over 4 minus 1. So what we have is 150 over 3. So I'm averaging about 50 miles per hour. Whoops, I'm not sure why that shifted like that. Let me try again. 50 miles per hour. There we go. And as you can see, there's a deeper explanation of what we just did. But really, if you remember the formula for the slope of an equation, you're okay with using that. Alright, so let's talk about this problem here. We have a quadratic function, and it is x minus 3 squared. And I want you to find the average rate of change for these two blue dashed lines between x's 1 and 3 and between 4 and 7. Now, we notice, if you look at this, it's kind of hard to tell where the y value of this particular point is. So here's what we're going to do. It says when x is 1. Well, let's figure out what the y value would be when x is 1. So instead of having x, we would plug in 1. Whoops. So 1 minus 3 squared. So what I get is when I do 1 minus 3 squared is I get 4. So the first point is going to be at 1 comma 4. And at this point, we are just working on question A. We will come back and do question B in a minute. So now we've got to find the second point. When x equals 3, what is y? So f of 3 equals 3 minus 3 squared. So I get when x is 3, y is 0. So using those 2 points, we are going to plug them into the formula for slope. So y2 minus y1 over x2 minus x1. So we have, let's go ahead and label x1, y1, x2, y2. So we have 0 minus 4 over 3 minus 1. So I have negative 4 over 2, which is negative 2. So for A, the average rate of change of this section right here is negative 2. And that makes sense because I'm decreasing from the left to the right. Alright, so I'm going to erase this. Hopefully you have it already. If not, you could go back and write it down. So now we're going to work on part B. Again, we're given x equals 4 and x equals 7. So let's plug them in to find out what we get. X equals 4. I get y as 1. So 4 comma 1. Alright, so when I plug in 7, I'm going to get 16. So, whoops, I was about to write 16 first. 7 comma 16. Those are my 2 points, and I need to find the slope between them. So x1, y1, oops, I wrote that backwards. I said it right. There we go. So we have 16 minus 1 over 7 minus 4. So 15 over 3 is 5. So the average rate of change here is 5. Okay? Ideally, we would like to use our units of measure, but you can look here, these axes don't have like miles and time. In our future problems, we will, so we'll be including our units of measure there. All right, so let's take a look at this problem. A varsity basketball team is selling team t-shirts in 1994. That's when they started. The average number of team t-shirts sold, S, is modeled by the graph shown where T equals 0. T equals 0 represents the year 2000. So, what is the average rate of change from t-shirts sold between 2000 and 2005? So what we're looking at here, the key piece of information is when T equals 0, that's the year 2000. So in the year 2000, we sold 500 t-shirts. Now you're thinking, Miss Norton, that only says 5. Be careful here. Sometimes it'll say in the hundreds, in the thousands. So in the year 2000, we sold 500 shirts. It's a pretty good deal. I think 500 is a good starting point. So now we want to know in the year 2005. So 2000, 2001, 2002, 2003, 2004, 2005, we get 5,500 shirts. So in the year 2005, we sold 5,500 shirts. So now we have our 2 points necessary. We can find the average rate of change for the t-shirts sold in that time period. So X1, Y1, X2, Y2. So, sliding down just a little bit, 5,500 shirts minus 500 shirts over 5 minus 0 gives me 1,000 t-shirts per year. So, shirts, I'm going to have to slide all that over. Shirts, I'll write that now that I have more space, per year. And that is your answer. Alright, so taking a look at this graph, it says that the graph represents Miss Norton's speed on a recent trip. For what time periods is her rate of change positive? Okay, so if you look at a graph like this, it says time in minutes. So I have been on the road for 60 minutes or an hour. And these are the speeds that I looked at the speedometer and said, oh, this is where I'm going. So at 10 minutes, I looked down and I said I'm going about 35 miles an hour. And at 20 minutes, I said I was going about 70. So chances are I am on the interstate going 70 miles an hour or so. And then maybe what I'm looking at is I'm going down here, maybe I hit some traffic, maybe I got off the interstate and onto Highway 92, and then maybe I was just driving around town almost home. So what we're looking at is this is the initial, 0, 0. I know that when I get in the car, it is not moving when I'm getting in the car. So that makes sense. So I'm looking for a positive rate of change. Well, this period right here is where I am growing or increasing. So anywhere from 0 to 20 minutes do I have a positive rate of change. Now, looking at the same thing, this time, what is the rate of change? When is it 0? So if you're looking at it, from the minutes of 20 to 30, I was going 70 miles an hour and I didn't change. So my average rate of change being a 0 occurred between the times 20 and 30 minutes. And then it says, when is my rate of change negative? So these are the times that I am decreasing. So between 30 and 60 minutes. Okay? So let's do another problem. This time instead of speed, it's going to be distance. So what we have here is a girl named Stacy. She's riding her bike. And as she's riding her bike, she gets farther and farther and farther away from home. All right, so let's say that it says she wants to know when the rate of change is the greatest. Okay, so if I look at this, I'm growing kind of steadily, but then all of a sudden, that might actually be maybe a really long hill, or maybe this was a full downhill track. Okay, Okay, this is the largest increase in her distance. She was able to cover, if you look at it, she was able to cover 20 kilometers in just 5 minutes. She is booking it. So I don't know how much of this is actually plausible, but we could say that this time period between 20 and 25 minutes was her greatest rate of change. All right, so when was it the smallest? Okay, so if you take a look at this picture, you might think this was the smallest rate of change. However, you would be incorrect. The actually smallest rate of change is here. We have 0. Okay, let's say that she got to her destination in 25 minutes and she stayed there. Or maybe she stopped and stood in line at the grocery store to buy milk when it was snowing. Okay, so this is no change. So no change is greater than just a little bit of positive change. So we have 25 to 30 minutes is her smallest rate of change, because remember, 0 is smaller than even 1 or 2 or 3. All right, so now we're looking at a different problem. This one has 4 parts. So it says we're going to estimate the rate of change for the last 4 years of given the data. So let's take a look. Data shows the number of houses sold in the southern region of the United States. So the last 4 years would be 2006 to 2009. So remember, in order to find the rate of change, what we are looking for is we need an x1 and a y1 and an x2 and a y2. Okay, let me make that x1 look more like an x1. There we go. So let's go ahead and find the rate of change. So part A, we have 202, excuse me, minus 559 over 2009 minus 2006. So 202 minus 559 over 2009 minus 2006 will give me negative 119. So we're looking at a negative 119,000 houses. That was the decrease from 2006 to 2009. All right, let's do part B. It says, using the rate of change you found in part A, write the equation in function notation for the last 4 years of the given data. Let x equals 1 represent the year 2006. So this would be year 1, year 2, year 3, year 4, which would mean that the year 2005 would be year 0. So that looks like a 13. Let's try that again. B. There we go. So we know we're going to use the formula y equals mx plus b. We're going to use function notation, so instead of y, you're going to put f of x. The slope is the rate of change that we found in part A, negative 119. X plus, and then your b is your y-intercept when x is 0, so 638. So this right here is the answer to part B. For part C, it says, using the function you found in part B, predict the number of houses that you'll sell in year 2013. So if 2006 is year 1, then we have year 2 is 2007, 3, 4, 5. So we're going all the way to 2013. So 2006, 2007, 2008, 2009, 2010, 2011, 2012, 2013. So that would be year 8. So we're going to plug in 8 for x. And what I get is I get negative 314,000 houses. And part D says, is this even possible? Is this a reasonable answer? The answer to that is no. You can't sell negative 314,000 houses in a year. All right, so our last question for the day, we have 2 funds, and I want to put in some money. I want to know which one would be in my best interest. So in the first question, I'm only going to put the money in for 2 years. Now, you got to know that if you're going to put money in for only 2 years, you're not going to actually make that much money. So you have to be careful about it. But if you're only going to do 2 years, you plug in a 2 for x in both equations. So in the quadratic equation, I would get $508. In the linear equation, which is the second equation, so this is our quadratic, this is our linear, I would get $510. So I would definitely choose linear if I was only investing for 2 years. Now for 10 years, when I plug in 10 for x, I would get $620 for the quadratic and $550 for linear. So I would definitely pick quadratic because it has a higher rate of change after year 2. Alright, that's it for rate of change. I will see you guys later.